So this is section 25.1, and our objective is to use slopes to determine parallel lines. And you'll recall a little bit from the work the last 2 weeks. If two lines have the same slope, they are parallel, and in a system of equations, that'll make no solution. So now we're going to get into some of the geometry section of our textbook, and the slope criteria for two parallel lines theorem. Theorem is simply just like a rule, right? A formula that's always true. So two non-vertical lines are parallel if and only if they have the same slope. And you saw previously examples of parallel lines that basically they just never intersect. So there's two shapes at least that we're going to discuss right now. There's more than two actually, but we're going to discuss these two. A parallelogram is a quadrilateral, which simply means a four-sided shape. That quad, right? If you were driving a quad, it has four wheels. A trike has three, so that quad is just a root prefix, and it means four. So a quadrilateral is a four-sided shape, and a quadrilateral with two pairs of parallel lines or parallel sides, and a trapezoid is a quadrilateral, basically a four-sided shape with at least one pair of parallel sides. And so a parallelogram looks something like this, right? Two lines that are parallel. And this is a crude drawing of mine, right? Because I'm not the best drawer, but these little arrows, when drawn through a line, indicates that basically these two lines, right, we'll call this line A and B, are parallel to each other. And then this double arrow means that these two lines, C and D, are parallel to each other. So you can see hopefully that it has two pairs of parallel sides. And granted, my drawing is not a perfect representation of a parallelogram, but for now it'll do. And then a trapezoid, let's draw a trapezoid, is only one pair, or at least one pair. And I'm just going to draw these little arrows to indicate which pairs are parallel. And it's the top and the bottom. So at least one pair of parallel sides. Now, if I was drawing a parallelogram on a graph, and I'm drawing it to the side here, right? The point, basically the corners of this figure, these corners, they're called vertices. And it simply means, that's the corner. And these vertices are ordered pairs in XY format. So you can see here, this parallelogram has vertices at 0, 0. So I draw a dot there. 2, 0. Draw a dot there. 0, 2. And at a point on the line y equals x. Well, y equals x has a slope of 1 with a y-intercept of 0. So that's going to be basically this line running through the origin. This is y equals x. So hopefully you can tell that the fourth vertice of this parallelogram, basically the fourth corner, right? If this line is parallel to some line of above, it's going to be right here. So there, a square, right, is a good example of a parallelogram. These lines here, right? That line there is parallel to that line there. And that line there, parallel to that line there. So I hope that makes sense. Now let's check out this trapezoid. It has a vertices, it tells you the points. Remember, vertices are just the corners of -4, 1. So we find -4, 1, 2, 3, 4, up 1, negative 3, 3, 1, 2, 3, negative 1, 4, negative 1, 1, 2, 3, 4, and then the coordinates of the vertex M are 2, 4. So I find 2, 1, 2, 3, 4. So here's your shape, and that's definitely a trapezoid. And hopefully you can recognize, if I were to identify which sides are parallel to each other, at least the single pair, it would be this top line and this bottom line, even though I'm not the best line drawer. Another key thing is the vertices are labeled. This is trapezoid JKLM. So point J is, it tells you right where it is. There's point J. So this is J. Let me use a better color. Right, that's point J. Point K is there. Point L is there. And point M. So essentially, line segment KL, which you represent like that, and lines is parallel to line segment JM. And KL has a slope of, looks like 1 over 2, and JM has a slope of 1 over 2. So as you can tell, they are in fact parallel. They will never intersect, and they have identical slopes. And the same is true for the square. The two vertical lines have an undefined slope, and the two horizontal lines have a slope of 0. So if line M is parallel to line N, and the slope of line M is greater than 1, then the slope of line N is greater than 1. So this is just kind of a way to think of it, that the lines are directly related. And since the lines are parallel, their slopes are always the same. Okay, so in these examples, explain whether the quadrilateral determined by the intersection of the given lines is a trapezoid or a parallelogram, both or neither. So I find that's going to help on this to have a graph of all of these lines. So let's get a graph going. So let's graph this first line, line L. Y is equal to 2x plus 3. So there's y-intercept of 3, slope of 2. Here's line L. Oh, I made a mistake here. Let me fix that. So we got one line here, and that's line L in red. And this one is 2y equals negative x plus 6. So if I have 2y equals negative x plus 6, I have to divide by 2, and that'll give me y is equal to negative 1/2 x plus 1. So now this line in purple, line M, I start at 1. It's going downhill. Down 1 over 2, 1 over 2, up 1 over 2, 1 over 2, and here's this line. So that's line M. This is line L. And let's keep going. Pick a different color. Hopefully the colors help you. So now let's try to graph this line. This one's going to start at negative 3. And it has a positive slope. Positive up 1 over 1. So this is line N. And then this last problem here, you have x plus y equals -3. So I got to get that over there. That's easily accomplished by just subtracting x from both sides. You get y is equal to -x minus 3. So I find -3, and that's the slope of -1. So then here's this line. And this is line P. So if this line was a parallelogram, right, you'd have one side would be parallel to the other side, and then another side would be parallel to the other side. So let's look at line L and line N and ask yourself, do they have the same slope? Same slope as each other? No. One has a slope of 2, the other has a slope of 1. So line L is not parallel to line N. And now let's look at line M and line P. Here's line M with a slope of -1, and line M has a slope of -1/2, and line P, here's M, here's P, has a slope of -1. Is -1/2 and -1 the same number? No. So M is not parallel to P. And so the answer to the question, is this a trapezoid or a parallelogram? Both or neither? This would be neither, because no lines. You don't have at least one line that's parallel to the other. And that's essentially the solution. So from here, we're going to go on to some homework examples, and hopefully this makes sense. And as you see more examples, it'll start to make more sense.